everybody. All right, let's take a look at the software in more detail for this robot. So first of all, we're in the folder and there's only a few key files. One of them is called core.py. There's the UI as the user interface. There's motion, sound, and vision. So let's look at the core first. So the core is the file that you run in order to start up everything else. It basically runs Python multiprocessing. So here, each of the sections are started up, the UI, the motion, and what basically happens is that we import the motion file as a module, and then we run one function inside of this module, and that function loops over and over again while the robot is running. So all of these processes are started at the same time, and they can run independently of each other. So like, for example, the motion can do a complex animation while the sound is also processing the chatbot. And they can do all of these at the same time and access more CPU cores. And this is quite good. So there is a data object that is shared between each of the processes. And this data object is called the world. And it's a dict data object, which means that there's a key and each key has a value. And so you basically, like, to get the sound state, you just put in the key and then you get the value, which is just a string called sleep. And this data object is passed down to each of these individual functions, so that each of the sections, like the motion and the sound, can access the same data, and it can update the data and synchronize the data in real time, because they will want to share data between each other. And then here is a list of the processes in the Python processing code. And then you start the processes. And then once all of the processes are finished, when the world shuts down, then they all finish and join. All right, so let's take a look at another section. Let's take a look at the sound section. So in the first part of the sound section, we're mainly just initializing a bunch of data. Here are just some functions that are like reading the sounds in different folders, because there are a lot of different sample sounds, and there's even books that I've included. So the books, each of the chapters are different files that have to be read, and then we just load that in. So here's the main function that is called, and this function loops over and over again when the robot runs. And it has just one input, which is this world data object, which comes from the core. So this data object here, that's the input. That's the input to this main function. And what the main function does is, while the world is powered on, it will just keep on looping, and it will start doing certain things depending on different conditions that the world is in. For example, if the sound state is in books, then we might want to pick a book and then play a chapter in the book. Or if the sound state is in a chatbot, then we might want to activate the chatbot function. And then after this main function is just a bunch of smaller functions that implement all of the features that the robot has. So for example, we have playing books, we have some idle sounds, we have some of these sounds, we have initializing the microphone, printing all the microphones of your system, printing all the speakers of your system, the STT, which stands for speech to text. So this is going to translate your speech into text so the robot can understand what you're saying. A function to play some MP3s. Here is one of the chatbots. So this is a GTP3 chatbot, and this has to run from another server, and we actually go to the server using an API key. So we make a call to that server, and then we give it, we give it a conversation, and then GTP3, the chatbot, tries to fill in the future of that conversation. And the conversation is just between the robot and the user. Here the user is named master. And then here we have another chatbot. This one is a simple pre-scripted chatbot. So this chatbot can load in a whole bunch of data, and then it's all scripted, so it doesn't do any neural network stuff. But it's all right. It runs pretty fast on CPU, but it's considered fairly simple. We have the chatbot function, and and then we have another function for modifying audio. So yeah, that's the sound section. All of the interesting functions and basically what the main function does. Let's move on to the vision. So as for the vision, the vision mainly handles the pictures that are being received onto the computer. And we have the main function here that is called by the core, and it just loops over and over again, and it receives the shared data object. And while the world is powered on, it will keep on looping, and when it's at the right state, it will start taking pictures, and each of the pictures are processed inside of this Python module. And we can do different sorts of image processing. We can try to find faces, try to find objects, try to do human key point detection. We can also do depth mapping, so try to find out how far objects are away from us. So yeah, and these are going to be implemented by the simpler functions at the bottom here. So some of the simple functions are just initializing the camera. We're using the OpenCV2 module to do camera capture, listing the available cameras, taking a simple picture, saving the picture. So Cascade, there is a face detector called the Cascade face detector. And this face detector actually runs pretty fast on CPU. So it's a pretty nice option to have, and this is what it does. So initiate face recognition. I played around with a module called face recognition that is actually able to recognize different faces, not just detect them. So you can put in your own face and it will know that it is you. However, I've had problems trying to make this work on Windows and trying to make it compile into a Windows program. So now we've got move on to the Khadas section. So this part is able to use neural networks and run the neural networks on the NPU that the Khadas computer has. So this is specific to the Khadas computer, and it is able to run the neural networks really quite fast. I think the last time I checked, it was just a few milliseconds for each image, which is really good. It's quite powerful. So we use their module. It's called KSNN, and all their file was actually moved to the vision section. And I was able to extract and write out a custom function to deal with using their module in order to run the neural network on the NPU. So basically what happens is it's initialized, and then we use some of their functions, such as this inference function for YOLO face, and then we receive the results of that inference. And then we do some custom stuff to draw the boxes and format the data the way that we want it. The data is actually usually then sent back to the core, so back into this world data object, so that the motion section can use the data. So basically what happens is we have an image that comes in, and then we run the face detector on it to find out where that face is in the image. And then now that we know where the face is, we give that data to the core so that everybody, all of the sections can know where the face is. And then the motion section will take advantage of this and then move the robot head so that the head is looking at the face. So we also implemented YOLO 3 for just the standard object detection. And this follows a similar format. I sort of extracted the code from the module and made it a little bit custom, but not too much. But basically, we initialize it and then we run it, given the one image, using this function here. And then we just draw some. Oh, for this one, we just draw the boxes around the image and then return the image. So it wasn't that custom processing here, but it's basically, so YOLO 3, what it does is detects the different objects. It knows around 80 different objects, and then it also detects where exactly that object is in the image frame. So then, yeah, that's basically what's shown here in the simple code. And we actually do, so for each of the, so when the world is in this vision state, then we do take a picture, and then we run the YOLO face function so that it detects the different faces, and it tells me where the faces are in the picture frame. And then we update the main data object with this data right here. And it can do this pretty fast, maybe like 10 times a second. Okay, that's good. Now let's move on to a different section, such as the UI section. So here in the UI section, there's a few things implemented. One is you can connect a Bluetooth PCB to the serial port. And for the Khadas, this is the serial port that's being used. And then you can read the Bluetooth data from this serial port. So here are some functions to do that. This section is for running a web server on your machine. So this is the function that the core runs, and it basically starts up a little website, and you can access the website while you're connected to the same network using a different computer. And this website will also allow you to control the robot. And we have a video showing the website there. So the website is hosted using Flask, and then basically we get a lot of information actually from the world, and we're able to use buttons to set different states of the world. For example, setting it to sleep or relaxed or to awake mode. So using different buttons on the website, we can change this world variable, which updates the world variable in the core. And then that regulates how all of the other sections work. So for actually using the Flask server, the code here is organized. First, we're just dealing with a bunch of buttons here, like the motion buttons. the sound buttons, the vision buttons. The code for the actual website and how it looks like is a really big HTML string. So this is a really big HTML string that that basically determines how the website looks like. And it is possible to add buttons and stuff here, and add sections here to deal with the button inputs. So it is possible to add functions, but this is actually a little bit clunky. I might move on to a different UI option later. So over here is another UI option, and this one just pops up a window on your desktop, and it's a much simpler function. And it itself, there's a lot of buttons, and because there's a lot of options. And yeah, so that's also another option where you just create a window and you have a lot of buttons for controlling the robot. And then you're able to use that as a method of control. All right, there's just one more section to look at, and then we're done here. So for the last section, let's look at the motion section. So the motion section deals with the motors and moving the robot. The first part of this section is going to just initialize a bunch of variables. So we're going to initialize all of the data associated with the motors. So each of the motors has an ID, and that determines what its name is. And it also has a type, and it also has some movement limits, and maybe some other stuff that can get updated later. So this is just the data table for all of the motors, and yeah, there are actually quite a few motors in the robot, and organizing them is important. A list of all of the motors are given here. So this the data is actually in a simple list, and all of these motors are also just in a simple list right here as a global variable. So we have the main function that the world calls, and it's just this one function that will loop over and over again, and it will do some stuff like there's a random move for the head, and then there's also targeted moving if it knows where some faces are, and also some body movements for playing animations. Different animations can be played. And after this main function, we have all the supporting functions. And for the motion section, there are quite a bit of supporting functions. There's quite a lot of them. We have a function to play animations. There's also a function to save animations. We have a function to mimic breathing, a function to do head targeting. So this will pick a random target in the list and then try to move the head towards the target. Yeah, I think this function does the same thing, face target, but you have input from the left and also right camera. You have random head movements, which actually look quite realistic. Yeah, random head movements look like the robot is just looking around for fun. We have moving the eyes and moving the mouth. In case you want to, say, mimic talking, then you want to do random movements of the mouth. And then we have a bunch of functions that are just for the motors. For example, checking the torque on the motors, initializing the motors. This is an important function where we do a lot of initialization. We have pinging the motors to check if they're alive. We can write to the motors, and we can also read data to the motors. So these are two very important functions, and they mainly control how you play with the motors. So if you want to control the motor, you basically write some data to the correct location on the motor, and then the motor will change. So the locations are called registers. So there can be a register for, say, the speed of the motor, and then you can write to that register and set the speed of the motor. So now the motor has like a maximum speed. Or you can set the position of the motor, and then it will try to go to there. You can also read data from the motors using the read function. So each of the motors has their register, which is where the data is located. So you can read the current position of the motor, which is very useful. You can also read other information, and yeah, that's a very important function. And then we have a bunch of smaller functions, like pinging all the motors, writing to a motor, writing to a bunch of motors, setting the speed of motors, a bunch of smaller functions, polling all of the motors, relaxing all of the motors, making all of the motors stiff. So these motors are quite smart. You can actually relax the motors, and in the relaxed state, you can move the robot around, which is really nice. And the robot will also know where the position is, because it's a smart motor. We have a record function for recording the movements of the robot, and you can make animations this way. We can read the serial ports, so the motor is connected to the computer via a serial port. We can then play simple animations, save the animation data, retrieve the animation data using these functions here. We can randomly move motors. And this function here is specific for the Khadas computer. So this function actually reads the accelerometer on the Khadas computer, which is it would be quite interesting to play around with this and make some more functions. But what this function does is basically we actually call a C++ script. It's located inside motion accelerometer, and it's a C++ script. And this C++ script will call the accelerometer on the Khadas computer, and we can get that data, which is quite nice. And then the final section of the code is just to allow you to test the motors. So when you run this file just by itself, not with all the other files, if you just run the file by itself, then you'll get a little command prompt. You get a little command prompt where you can enter commands such as body, core, arms, or you can enter different commands, and then it allows you to test the motors. So you can pull a specific motor and to see if it's alive. And this is just very useful for testing. It's also pretty useful to record animations just using this section here. Alright, so that's a basic overview of all of the different sections of the code. To summarize, everything begins with the core. This is the only file that you run, and it starts up all of the other sections, like the motion, the sound, the vision. And it has a shared data object with a lot of important data that the robot uses. And then we have all of the individual sections, such as the sound and the vision. And then you have the main function. In each of these sections, you have a main function that loops over and over again. And then usually what this function does is it gets some data, it processes the data, and then it gives the data to the core, or it plays back something, like it plays back some sound, or it plays back an animation. And that's basically how the robot works. Below the main function, you'll find a bunch of smaller functions that are used to create some of the final results, like some of the actual things you want the robot to do, such as playing books, or playing idle sounds, or working with the chatbot, the different types of chatbot. So yeah, I hope you enjoyed this overview of the code, and thank you for watching.